Welcome back. So we have a general understanding now of the idea behind infrastructure as code and some of the tooling and some of the categories infrastructure as code is built on from the previous lessons. But why even adopt an infrastructure as code approach to managing your IT environment? Well, in this lesson, we'll take a deeper look at the benefits infrastructure as code brings to the table. In this lesson, we'll be looking at change history with version control systems, eliminating siloed knowledge with your teams, the efficiency through using reusable code, the consistency of your environments, security and governance, testing and QA benefits, reducing human errors, deployment speed, and even as a disaster recovery solution. Okay, so let's start diving into all these benefits of infrastructure as code. So the ability to keep your IAC files in a version control system is an important benefit of adopting an IAC approach to managing your infrastructure. When your IAC code is all committed into a code repository in something like GitHub or GitLab, you get a built-in audit log or history of all the changes taking place in your infrastructure. Now, all this is assuming you have strict policies and mechanisms in place to ensure that the changes performed in your environments are all done through IAC and not manually. And this is actually a very important point, which we'll get into in future lessons. You don't want your live environment configurations to drift or differ from what you originally defined in your code. So with the history of changes available to us when we have all our code change commits through a version control system, you have an easy way to troubleshoot if things go wrong. You can identify the exact changes that were performed with your infrastructure and either fix those or simply roll back to a previous working version of your infrastructure code. Another benefit of using IAC is it prevents the problem of siloed knowledge about your infrastructure. The details of how your environment is configured aren't locked in the brain of a single person or a specific team in your organization. Infrastructure as code provides a way to have business continuity for your important infrastructure design and configuration. If someone leaves the company or actually uses the unlimited vacation perk offered at the organization and they're unavailable for weeks at a time, you need a way that other people in the organization can easily understand the existing state of your infrastructure and make any necessary changes to it. Now, as a beneficial side effect to writing code for your infrastructure, you're somewhat developing a form of documentation for how things are configured in your environment. Now, others on the team or in your organization should be able to read the code and, for the most part, get an understanding of how things are deployed and configured in your infrastructure. So if one of your cloud engineers on the team makes some infrastructure changes the night before they go on vacation for a month, that's no problem. The rest of the team can simply review the code changes that were done and quickly understand what was added or what was changed. Next, we get to take advantage of the efficiencies of reusing our infrastructure as code. We can write our code once and then reuse it over and over again. Doing your infrastructure provisioning, configuration, and ongoing operational tasks manually is very time-consuming and not very enjoyable. The automation infrastructure as code offers us to perform many of these activities automatically makes engineering and development teams much more efficient. The reusability benefit has some initial trade-offs to consider. While having every infrastructure provisioning and configuration task defined in some automated code sounds amazing, don't forget that for the most part, someone needs to write this code. So the time investment of creating the infrastructure as code in the first place can take a lot of time. If you have a task you need to perform a few times a day, like launching a virtual machine, but it only takes under a minute to do this through the web-based console, is it worth spending a few hours writing automated code for this? Well, it may be a quick and easy thing to do manually, but how distracting is this task to do other work? How long into the future do you think you'd need to be doing the same tasks? Months, years? Maybe it's not just you. Maybe there's 100 other developers and engineers in your organization that do the same quick activity a few times a week, and they need to do this for the next year or two. So what does that simple task look like now in terms of business efficiency perspective? If we take this simplified example and think about all the time involved, it takes us that 1 minute to launch a VM manually. Okay, that's no big deal. But if we have to do that every business day, so roughly 260 times a year on average, so 260 minutes a year we spend on launching a VM. But in our example company scenario here, there's 99 other colleagues that do the same thing as us. So now that's 2,600 minutes or roughly 43 hours every year just spent launching VMs. So the time investment of taking an hour or two to write some reusable code to automate the provisioning of VM suddenly seems like a very worthwhile investment. Now, another key benefit Infrastructure-as-Code provides is the consistency it can offer. With your infrastructure resources deployed and configured through Infrastructure-as-Code, similar resources would all be set up the exact same way. You no longer have 50 different people in your organization deploying things manually and having each resource deployed and configured a little bit differently, making future maintenance and operational activities a nightmare. With Infrastructure-as-Code, you can often use simple variables or parameters in your code to have the same general code function reusable across different environments, like your development, QA, production environments. And you can get consistent resources and configurations deployed across all your environments or cloud accounts, so you know that what you're working on in the development environment, and then validate that in your QA environment, would be the same as what exists in your production environment. Now, going back to our simple launching a VM example, you could set up your code so that the VM image or operating system and all that required installation and configuration steps are all defined as the baseline function of the code, and then have a parameter that allows the user to define an environment variable that determines what environment the VM should launch in. So the underlying VM creation and deployment code parts are all consistent and would be exactly the same regardless of what environment the VM was actually pointed at to launch in. Now, this is just a simplified example, but we'll be getting into more of these reusability concepts in the future lessons, especially using the power of Terraform to help us out with all this stuff. So moving right along, we have a bunch of security and governance benefits as well. Now, this somewhat overlaps with the other benefit areas, but it's important to look at IAC from a security lens as well. So with Infrastructure-as-Code, we have a ton of control over how our infrastructure resources are deployed and configured. If your organization has a number of policies or compliance requirements around security and data governance aspects, a lot of these can now be baked in with the Infrastructure-as-Code concepts. So if you have a resource tagging policy with mandatory tags for metadata for your resources deployed in the public cloud environments, you can define all these tags to make sure they're always there when you add a new resource when it gets launched. Or maybe you have certain encryption requirements for your data in transit, at rest, or both. These encryption standards can be defined when you build your IAC code so that anyone using this reusable code to launch a new resource from it already has the latest security and governance controls all in place without needing much thought or consideration from the person actually launching the resource. So going back to our simple VM launch example, maybe someone from the development team just needs a new VM for a new feature they'll be working on. The developer's just focused on getting their new code out the door. They may be a wizard at application development, but maybe not necessarily up to speed on all the latest company policies and changes to different regulatory or compliance aspects the organization has to comply with now. They're also not likely security specialists to really understand all the nuances of how to secure the VM. They're simply not aware of what network subnet the VM should be using, what network ports should be open or locked down, what storage volume encryption standards should be adhered to. They simply need a VM to do their work, to run their application on, and that's simply the extent of their concern. With Infrastructure-as-Code, we can build in all these security and compliance aspects so they're transparent to the end consumer of the resource. We can enable teams to do their work efficiently, get what they need to do their job, but still have all the built-in security and compliance guardrails in place on all those resources. Now, using Infrastructure-as-Code also enables us to take advantage of testing and quality assurance of our infrastructure itself. Similar to application code, we can build entire continuous deployment pipelines for our infrastructure code. Pipelines that have various testing and validation stages where we can ensure our infrastructure changes work as intended and play nicely with the actual applications running on them in the environment. Now, there's a ton of additional tools and solutions available in the broader DevOps tools area that can perform debugging and testing of even your infrastructure's code files as you write them. And this is the whole idea of shifting left, meaning that you try to detect and fix the issue as early as possible within the development lifecycle or pipeline. It's much easier and faster to update code as you're writing it and developing whatever it is you're working on, rather than to find out that there's an issue once that change gets put into production. Typically, the costs and effort of fixing a problem are a lot higher the further to the right or the closer it is to running in production, compared to the left, where you're just starting to write the code. Now, some of these testing tools can integrate right into your IDE as plugins, where there are product solutions that can perform scans on your IAC code and advise if you're missing any best practices, or perhaps even have security areas you've overlooked. You can trigger these scans as new IAC changes or additions are made to your code and committed into your version control system. Now, all this is getting a bit off topic, but just be aware that there are a lot of testing and quality control benefits of implementing an infrastructure-as-code approach to managing your infrastructure as well. Now, up next, we have reducing human errors. So this largely overlaps with the consistency, repeatability, and testing benefits you can gain from using infrastructure-as-code, but a lot of this boils down to reducing human errors. If you give anybody a task to deploy 1,000 virtual machines from scratch, doing each step manually for each one, no matter how careful they are, the chances are that 1,000 of those VMs won't be set up exactly the same way. Maybe a software package installation is missed on one or two of them. Maybe there's a typo in a config file on a couple of the VMs. I think you get the point. But with infrastructure-as-code, you can have tested infrastructure code that you can reliably deploy and ensure you have consistent resources. Now, next on our list of infrastructure-as-code benefits is deployment speed. Now, with all the automation aspects of your infrastructure code now, deployment activities are blazing fast compared to the manual alternatives. Typically, the only bottleneck is the speed at which your cloud provider or the physical resources can process the resulting deployment requests from your infrastructure code. A deployment of potentially hundreds or thousands of resources could be triggered in a matter of seconds. And last but not least on our list is disaster recovery. Now, while again, this is a blend of all the above benefits and sort of a potential use case of all of them combined, but infrastructure-as-code can help us out as part of an overall disaster recovery solution. If some of your infrastructure resources fail suddenly and need to be redeployed, we can potentially relaunch the exact replacements for those resources since we have all of them defined in code. Or what if an entire cloud provider availability zone or region goes offline and you need to redeploy your infrastructure elsewhere? Well, depending on how you have your infrastructure-as-code configured, you can likely just switch around a few parameters to define a new region target and then redeploy everything again. So in theory, you'd have an exact copy of your infrastructure running in a different region or location in a very short time. Now, maybe the disaster is created internally at your organization. Maybe you roll out a new infrastructure design to support a completely reworked application your company is launching, and the changes needed consist of hundreds of networking, DNS, different compute and storage and database resources. What if things go wrong and your core business application stops working and your critical business systems come grinding to a halt? Well, now the pressure's on to try to restore everything to a good working state. Trying to troubleshoot the issues and undo all the changes when there's a ton of complex changes deployed all at once could potentially take hours or days to complete. So what do you do? Well, with infrastructure-as-code, assuming you have all these recent changes in a version control system, you could potentially roll back your entire infrastructure to a last known good state in a matter of minutes. Now, of course, I'm oversimplifying all the considerations needed around a successful DR strategy here, but just be aware that infrastructure-as-code can offer a lot of benefits around DR capabilities as well. So I hope after all this, you get a sense of why there's so much popularity around this infrastructure-as-code stuff. There are a ton of benefits infrastructure-as-code can bring organizations that adopt it well. Now, all this is just the tip of the iceberg in terms of benefits of infrastructure-as-code, but we've covered all the core areas here, and you'll have a solid foundation of understanding why companies around the globe are quickly adopting infrastructure-as-code methodologies and using tools like Terraform to help them out. Now, we have a few more lessons on some of the foundational theory stuff before we get our hands dirty with Terraform directly, but hang in there and don't skip over these lessons, as the information will be helpful for you in the rest of the course and, of course, for the real world. So thanks for watching, and I'll see you in the next lesson.